All right, so working on those growth and decay word problems a little bit more, looking at our front sheet here. So any quantity that grows or decays by a fixed percent, which that is a key word right there, a fixed percent or regular intervals is said to possess exponential growth or exponential decay. And again, that word right there, the fact that it's a percent, that is like your number one sign that you're dealing with an exponential function instead of a linear function. So as I was saying, those linear functions, those exponential functions, they are very similar. So that's one of the ways that we tell the difference between them. As soon as we see a percentage, that tells us it's going to be an exponential growth or decay. So right here, this is our basic formula that we use for our exponential functions. Y equals a times b to the x. That is our exponential formula. Y is our new amount, just like it was for your word problems last week. It's still representing your new amount, whatever that new amount is going to be, whether we're dealing with investments in a bank account or we're dealing with bacteria or some kind of radioactive substance. That is always your new amount. A is still your initial amount. How much did we start with? So how much money did we invest in our bank account? How much of the bacteria did we start with? How many animals in the population? Whatever the situation is, A is still going to be that new amount, or I'm sorry, that initial amount. Because I ran out of room, I'm going over here. B represents what we call our growth or decay factor. B is our growth or decay factor. So that is what we're actually growing by or decreasing by, depending on whether we have growth or decay. Now, you did deal with this a little bit in your last day's worth of notes. In your equation from last time, your B came from when you added or subtracted that percentage. So if it was growth, you added your percentage in there. If it was decay, you subtracted your percentage. But once you add or subtract that value to 1, that gave you your growth or decay factor. So we did deal with it a little bit last time. And X still represents your number of times. How many times is whatever the situation dealing with happening? So then a lot of times the questions that they like to ask is they want you to be able to look at the equation and figure out if you have exponential growth, or look at that equation and be able to tell us that it is exponential decay. And so the way we do that, the way we figure out whether it's growth or decay is by looking at that B value. So if our B value in the equation, which is the one that has the X attached to it, if that is greater than 1, it is a growth problem. So 1.05, let's say you had a percentage of 5%, 1.05, that would be growth. It's still greater than 1, not by much, but it is still greater than 1. Your decay, your B value is going to be between 0 and 1. So it's going to be a fraction, 1/2, 2/3, 3/4. B is never negative. B is always a positive value for these word problems here. All right. Let's take a look at our examples we have on the inside. So our problems are going to be a little different this time because we're not going to get a percentage for today's word problems. But there are still going to be some context clues that we can use to be able to tell us that it is an exponential growth or decay problem. So looking at our first example, we have suppose 2 mice are living in a barn. The number of mice quadruples every 3 months. That word quadruples, that is your clue that this is exponential. Quadruples means it's being multiplied by 4 each time. So they tell us that here is the equation, f of x equals 2 times 4 to the x. How many mice will be in the barn after 12 months? All right. So again, I'm just going to rewrite first the equation that they gave me. F of x equals 2 times 4 to the x. So just to kind of review the different parts that we were dealing with last time, our A in this problem is the 2. Your initial amount is always right there in the front. Our B value this time is a 4. That is our growth factor. Throwing some vocab in there, growth factor. And we know it's growth because the B value is greater than 1. So that's how I know this is definitely a growth problem. Plus, it also told me that the mice population was increasing. So that was our other context clue here. So the one thing that we need to figure out, though, is how many times is this happening? X represents the number of times that in this situation, the mice population is increasing. How many times does that happen? It quadruples every 3 months. So how many times does it quadruple in 12 months? 4. How do we get that 4? Yeah, divide by the 3. It quadruples 4 times in 1 year. So that is what we're going to plug in for our x, is the fact that it quadruples 4 times. So 2 times 4 to the 4th. Which, what does that give us? 2 times 4 to the 4th. 4 to the 4th is not 16. 4 squared is 16, yes. 4 to the 4th. You guys remember the exponent button on your calculator? It's this little guy. What is it? I feel like it's higher than 256. 4 to the 4th is 256, but then you got to multiply it by 2. So there are 512 mice, which is gross, and which is why people have barn cats, so that they don't have 512 mice. So that one wasn't too bad. They did give us our equation already to use, but we can easily plug it in. So like that's what we're going to do for our next one here. Did you talk about half-life yet in science class? Half-life? No? No? Maybe later in the year. Whoever's music's playing needs to stop. So half-life is the time period it takes for a substance to decay halfway. So like let's say I had 20 grams of something. Half-life is how long it takes for me to have 10 grams of it instead of the 20 grams. Okay. So here we have a laboratory has 37 grams of a sample of polonium 210. The half-life of that is 138 days. So what that says is it takes 138 days and then half the substance is there. And then another 138 days and half of what that was is there. So our first question is, how many half-lives happen in 690 days? So we will divide 690 days divided by the 138 days that it takes for a half-life to happen. How many of them are there going to be? Five half-lives. So that substance in 690 days, it will break down halfway 5 different times. So to use our equation, our initial value is the 37 grams. So our A is a 37 here. Now this is a half-life. So our B value is a half. So 0.5. Or you could use the fraction 1/2. Either one is fine. And then our X is 5 because we determined up in part A that it was going to break down 5 times in those 690 days. So I'm just going to rewrite my formula quickly that I'm going to use a times b to the x. My a is a 37. My b is 0.5. And my x is a 5. That is a multiplication dot right there. And then I have my decimal 0.5. And then we'll use our calculator. 37 times 0.5 to the 5th gives us 1.15625. 5 grams is how much we will have left. So you just find your initial value, how much you start with. What is our growth or decay factor? This one was a decay because it was less than 1. 0.5 is less than 1, so that one is a decay factor. How many times does it happen? All right, let's take a look at number 3 here. So number 3, half-life of carbon-14 is 5,700 years. If there's 20 grams are present now, how much will remain in 11,400 years? Okay. So how many half-lives occur in 11,400 years? I'm going to take that, divide it by the 5,700 because that is how long it takes for one half-life to happen. So when we divide here, how many half-lives are occurring in 11,400 years? Anybody? Come on, use those calculators. It is 2. 2 half-lives. So now we're going to actually figure out how much of this substance is left. I'm going to make myself my little list over here. I just figured out my x to be 2. There's 2 half-lives happening, so my x is 2. It happens twice. How much did we start with? Nope. We started with 20 grams. There's 20 grams present now. And then it's half-life, so our b value is a half. Half-life is always 0.5. So a times b to the x. So 20 times 0.5 squared. Go ahead and multiply that out in your calculator. Let's see what we get. 20 times 0.5 squared. 5 grams. There we go. So again, you find that initial value, that's your A. Find whatever our growth decay factor is, that's your B. And then figure out how many times it is happening